Okay, let's see now. Right, I'm running a test. I've only got one coil and it's only half wound actually. I was a bit worried I'd run out of wire for the other bobbin which isn't wound yet, so don't expect miracles at this stage because this is running at about 100 RPM. About what? Ooh, let's see, a record player, an old 78, that's 78 RPM, isn't it? Right, well, this, if you look at the wobble, you can get an idea that this is about, what, probably 100, 150 RPM. It's very, very slow speed, right? I've got it geared on this motor. The motor, you can see from the belt is running very slowly. And the belt is driving this pulley here. And if you look at the pulley, if we get the light on it right, I need to put a white dot on there, I suppose. I haven't got an RPM meter, but you can see it's running quite slowly. Now, one coil at the moment is producing 0.5 volts. Well, that's not a lot. Okay, right, let's look at current. And let me just get the meter in a better position. Right, so still I'm quite get my light in here. Right. Well, let's check. I'm on volts at the moment. Currently on 20 volt range. Right, so let's see what current is. Oh, let's look at frequency. Frequency is 0.23 kilohertz. Now let's look at the current. Damn it. Alright. I've had this meter for years. It's pretty tight. My current is about 8, well, it's about 17 milliamps. Well, that's not bad. Actually, that's pretty good because I am running it fairly slowly. That's the current, and that's just one coil, right? Now, this is the important thing. I am using a Duff motor to drive this. This motor here is Duff. I mean, look, it's slowing down. This motor is Duff. I'm using a Duff motor simply. I've got some good motors. I just didn't want to burn out a good one. I thought I'd test it on this Duff one. But the current on. Oh, I've knocked the power off now. Right, hang on a minute. Right, I'm using a Farnell power supply, which is it's a really accurate power supply. It was made by Farnell Instruments Limited years ago, Weatherby, Yorkshire, in the UK. And current at the moment is about 60 milliamps. Let's see, 10, 20, 30, 40, 50, 60. It's about 70 milliamps, but it's actually the motor's faulty and it's using more power than it should. But it fluctuates, and I've got it current limited. Right, okay. And back to the meter, and while that's using 60 milliamps, it's actually short circuit on the coil is actually 15 milliamps. Right, okay. And I haven't even balanced this up yet. There's a lot more to do yet. A hell of a lot more to do yet. I mean, I've got to run this without the can on, you know, the metal can. I've got to take it off and see what difference that makes. I've also got to adjust my biasing magnets on the outside, because the biasing magnets affect the magnetic flux where the flux meets in the middle on the cage, because the cage will determine where the power is generated. And if I've got the magnetic field meeting further up nearer the magnets, then I'm not going to generate much energy. So it's important to get the magnetic flux balanced so that it's peaking where the coil is, basically. And I may have to add some more steel bars in the centre. But anyway, this is said. This is the preliminary first test. I wasn't going to do this. I was going to do it live, but I thought, bugger it. I mean, I don't want to disappoint everybody. We need to get it balanced up a bit. Anyway, so I'll put this meter back on volts. Right. I'll just get light on it. Right, well, it's actually slowed down a bit. We're actually at 0.4 volts at the moment. As I said, this motor here that's driving everything is duff. I'm going to swap it out, actually. I'll just show it. I mean, I've got loads of these motors. Right, I've got another motor here. And this is one. These are CD players. This is another one. I can't get this flipping thing off, though, at the moment. I can't get this off. It's stuck on there. I'm going to have to heat it on a soldering iron and get the damn thing off so I can swap it out. Basically, this motor up here has got a short circuit in it, and it's actually drawing more current than it needs to be doing. And this one here is a much better one. So I'm going to swap this out now in a bit and put this one on there, because the other one keeps varying in speed and I can't get stable readings on it. So, but as you can see, we are running quite slowly, and the current draw on, considering it's pushing and pulling on here, and this, do you remember when at this low speed this rocks side to side really crazily? Well, I'll just show you what happens when I disconnect it, right? Disconnect one power lead. These clips are horribly slippery, right? Now you'll watch it, it'll rock. It really rocks really crazy at that low RPM, but once it gets past that point, it's stable. So as you can see, the meter's back at 0 now because we're stationary. And yeah, I'm actually kind of chuffed. I'm kind of chuffed because okay, I was expecting some miracles on one side of me. I was hoping I was going to get like 12 volts straight away, but that was being really over optimistic. But bottom line is, it's working, even though it's not working 100%. But that leaves a lot of room for me to experiment and improve it. I mean, that's the whole point, is to get something that works. And as long as you know it's working, there's room for optimizations and improvement, and that is what we've got. We've got room for improvements, and even my distance between my platters. The distance between my platters and the actual magnetic ends on here, there's a lot of stuff I can do here to improve this. I mean, this is a very tiny little ring on the end. I mean, ideally, I want to use a much bigger one. I want to use a much bigger ring, like that, like the, hang on, where is it? Like one of these bearing type rings, but these are huge. And I was a bit worried about getting it in, because if you look, if I stick one of the rings on each end, I'm not going to get my platters in there. I would have to shorten my, I'll have to shorten this and move the ring right close to that. That I could probably do it. So I might go to engineering firm and get some rings, some steel rings made. It actually helps the magnets pass by without sticking. So I might actually get some of these rings, made just specifically for all this. If I shorten my end a bit, I will get them in. No problem about that. These are the sorts of things I had to estimate and calculate, and I didn't want to leave myself no room, because if I ended up going outside my the length of my drive shaft, I'd have to have another drive shaft made, and that cost me like 15 quid to get that made. So I don't want to be going outside my limitations. And obviously I could make another ring on this side, but as you can see, the little rings that are on there, the tiny little things, I had them made previously for doing initial experiments, and they do work, but I'm not getting the amount of magnetic flow through there that I really want, and that's part of the problem. I'm not getting enough magnetic push and pull, and my actual magnetic gauge in the center, it's barely moving, which is another thing. Do you remember before I was doing them static tests? Well, look, I'm moving my rotors manually, and if you look, my magnetic gauges are not even moving, which proves that I'm not getting the magnetic flow that I was with the test. So I need to get my magnetic flow up a lot more than what it is at the moment. So that's another issue which I have to work on. And considering I'm only getting half a volt at the moment, that's pretty good, because I'm barely tickling this thing, you know. Anyway, just a little video update.